All right, hello and welcome to week 2 for Introduction to Python Geography 473. 673, last week we just covered some basic rules and syntax, got a little bit more familiar with Spider, the IDE we're going to be using, practiced loading some packages, and even got introduced to some for loops and a little bit, just a taste of some more advanced things that we'll be doing here in this course. Week 2 is we're going to be focusing on practicing our Python programming skills, specifically focused around using two of the main packages within Python. So those two packages are NumPy and matplotlib. NumPy is short for numbers Python, and basically it runs the show. It's the engine underneath the hood for a ton of mathematical related packages. So NumPy is super crucial to the success of a lot of different packages, and getting familiarized with it can really help you down the road. Matplotlib is the engine under the hood for a ton of plotting packages and plotting routines that you'll encounter when coding in Python. So both of these are absolutely crucial. You'll see these all over the web if you're just looking for help for different Python things. You're trying to do various Python thing. Anything with numbers, NumPy can do it. Anything with plotting, matplotlib can do it. So the first thing I'm going to do here, I'm going to open up Introduction to NumPy in a new tab, and I'm going to open up my Anaconda Navigator. And so here is NumPy. And so as I said before, it's short for numerical Python. It is super powerful with arrays. So an array is just a two-dimensional data set. It can also work with, but NumPy can also work in 3 dimensions and 4 dimensions. It can work in any n dimensions. It's incredibly powerful. So NumPy is great for spatial data. It is really great for just crunching numbers, just doing basic math. It can do spatial math. So imagine NumPy can be a grid of lat/lon values with temperature recordings for those grid cells. So NumPy is just pretty powerful. So it's also powerful for mathematical functions, for linear algebra, Fourier transform, and random number capabilities. It's used, as I said before, it's an incredibly popular dependency. So we installed yesterday, we installed CartoPy and MetPy, and in the very first introduction to Anaconda, just getting started and installing everything, we installed those, and NumPy is a dependency for both of those. So some nomenclature to get familiar with is array, vector, and matrix. So an array is an ordered collection of data items such as timestamps for October 1st, 2019. So for example, if you have October 1st, 2019 at 1 a.m., October 1st, 2019 at 2 a.m., so on and so forth. A vector is just a one-dimensional array, so think temperature data for Newark DE over time. So let's say we have daily temperature data, temperature data over time. You can just think of it like that. 50 degrees on Tuesday, 60 degrees on Wednesday, 62 degrees on Thursday, so on and so forth. A matrix is a two-dimensional array, and think tree cover density over the United States at 1 kilometer resolution. So we have 1 kilometer sized grid cells over the entire United States, and in each grid cell we have a value for the total amount of tree density. So just get familiarized with that nomenclature, and NumPy arrays are just super powerful, and what we can do with those is we can perform a number of functions, such as we can sum up, we can count the sum, we can use sine, cosine, tangent, max and min, mean and median, square root, so on and so forth. There's a lot of different things that we can do here. But first and foremost, what we need to do is we need to open up our NumPy package. So I'm going to launch Spider here, wait for that, and sure, I'll restore it. Okay, and this is the script from week 1. So I'm just gonna open up a new script here, and I'm gonna copy that in. So we're gonna import NumPy as NP. So what that means is when we actually go ahead and run this line, it's successful now because we're in our second block in our console. That means it succeeded. Now NumPy, we do a NumPy dot and hit tab. There's nothing, no recommendations there. Why? Because Python is, in this specific instance of Python, we have opened NumPy as NP. So we need to call it as NP. So hit np dot, hit tab. These are all of the different functions that we can use here. So there's a ton of different functions that we can play with. And where am I? And in particular, all of these ones. So let's actually go ahead, let's create a NumPy array of 3 integers. Let's come over here. Here we go. Notice that now that I have this, that yellow triangle went away. Let's run all of this right here. Go to our variable explorer. There's A. It's just 1, 2, 3, and I'll print it out. Here's what it looks like: 1, 2, and 3. So we can print out the shape of this array. A.shape is 3 rows, no columns. We can print out the number of dimensions, a.ndim. There's only one dimension, so one-dimensional array. We can print out the data type, a.dtype. It's an integer. It's a 64-bit integer. We can also do an array, instead of an array of integers, we can do an array of floats. So let's have B is a NumPy array of 1 point, 2 point, 3 point, 4 point. Now if I do b.dtype, it's a float 64. It's a 64-bit floating point. And don't get too hung up on the types of data here. There's just different ways that the computer is storing these. In particular, the way that your processor and RAM is holding and storing these values. So don't get too hung up on them. They're just numbers. And then we can run a shape on b.shape is 4. And then we can get into some more advanced functions like Npa Range. So let's come over here. Let's type np.arange. Let's select it. And then let's read about it here. So I need to have that parenthesis, and then I get a little definition right here. So it's going to return evenly spaced values within a given interval. So we give it a start, we give it a stop. And then we can also give it a step, so number of intervals to step by. So typically it's just 1, unless we specifies otherwise. So let's just say we want np.arange of 10. That's going to give us 0, 1, 2, all the way till 9. Remember that Python is 0 indexed, so it's 0 up until 10. So you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Additionally, if we want to actually use this a little bit more and expand it, we can say, okay, we want a range of a NumPy array range of 1 to 10, start at 1, end at 10, by 2. And I want the data type to be a float 32. Now if I print A is 1 point, 3 point, 5 point, 7 point, 9 point. So remember, we went from 1 all the way up until 10 by 2. We can also use Lin Space, which is linear spaced entries, and this is also another useful thing. So we can do 0 to 10 with a total number of 5. So now we have 0 point, 2.5, 5 point, 7.5, and 10 points. So notice that it actually included it. That's because it's a different function. That's because we're using NumPy linear spaced, which is actually will include that final value for you. We can use radians. We can convert a degree to radians. and vice versa. And then we also, this is another really important thing with NumPy, is we can declare not a number values. Not a number is something you encounter with virtually all data sets, and what it means is it's basically a blank grid cell. We just don't have data for that particular point on a map or that specific time in a time series data set. So what we can do is we can say A, print out A, and let's say A, let's grab the first value, and let's say instead of 2.5, we want that to be nan. Now we print out A and we have 0, and then NP nan, which is not a number, 5, 7.5, and 10. So now that you're getting your feet wet with NumPy, let's actually go ahead and let's do this little exercise here. I'm not going to go through this, but I encourage you to do so. Convert the following degree list to radians using a for loop. So actually, you know what? I will go through with this. Let's do this first one together at least. So let's say I have a deg list, which is my degree list. I have a rad list, and I'm just going to store it as a blank, empty list. And the way I'm going to do that is just by having these brackets here, like I normally would for any other list, and I'm not going to put anything inside. So the for loop. Remember that a for loop is tabbed over for the contents inside, and then we give it a conditional up top. So let's start with a conditional for d in deg list colon, hit enter. Notice that we're tabbed over here. We want to say rad list d is equal to np.radians of d. Now, let's go ahead and try this out. Gotta select everything that I need, click the white button, and run. And now notice my error right away. What's going on here? Okay, so we have d is my temporary variable. We're looping over everything by d. And by the way, whenever you're done with a for loop, just go back, tab back over, and that'll signify that you're done. But what's going on here? Let's print out d. Let's print out our temporary variable. D is equal to 15. Okay, yeah, that's our first element of degree list, deg list, so that's fine. We want to take the NumPy radians of that, so let's go ahead, let's copy that over, let's just debug this. Okay, so that worked out, that makes sense, but what's going on right here? There is no 15th element, we're out of range. So I can do a couple things here. First, let's try this. Let's see if we can just pop in something random here. No, we can't do that. So this is already different than R. For those of you who took the R phase with me, remember we did this in the last section. Instead of specifically placing elements into a list like that, we have to use append. So we have to use radlist.append, and we want to append it by NumPy radians of our d from deg list. Now let's rerun. It ran successfully. How do we know that? Because we're now at our next input line, and now we can print out rad list, and sure enough, there we go. Radians for each degree in that degree list. Just double check what d is. D is 90, which is our last element within our deg list. And yeah, that all makes sense. So that's how we have to go about doing that. We can't do it the same way we did it in R. We have to use the append function. And yes, it is a little bit different as well because we are appending using the append function directly from this list. So we have to use the dot feature. So rad list dot append as opposed to doing something like append rad list by value, like so on and so forth. So we can do it that way as well. we can run numpy append. So that would be another way to go about doing it, but I would just do it this way. It's a little bit more intuitive. So the other thing that we can do here with NumPy that's super powerful is array operations. So we can add two arrays together. Let's say we have these arrays, A and B, copy those over, and let's run those. So A and B, 1, 2, 3, 6, 7, 8, and we can do C equals A plus B. Run that line, print C, and we have 7, 9, 11. 7, 9, 11. We can do A times B, 6, 14, 24. And now watch what happens if we try to do this with a list as opposed to a NumPy array. So I'm going to let's remove this NumPy array right here. And let's just go to our list command. Remember, we just signal we want a list by using these square brackets. Now let's add them together. And now let's print C. C is 1, 2, 3, 6, 7, 8. So what we did is this is a way to append one list to another. You add these two together. So, but we didn't want that. So I'm going to Control Z this and get my Numpy Arrays back. And we actually just want to add these together, and we have 7, 9, 11. So remember, we have this nice function called Numpy Linspace. And this is a really nice function, and it just takes a linear spacing of two specific variables, and we can actually do this from numpy.pi. So this is the value of pi, negative value of pi to the value of pi, and we want 10 evenly spaced numbers. So let's actually go ahead and run that. And there we go, negative 3.14, and then there's 10 values up until we get to positive 3.14. So that's what Linspace is. It's a nice little function. We can take the sine of that, we can take the cosine, whatever we want. Now, the other thing that NumPy does is we've only been working with one dimension so far, but NumPy can do 2 dimensions and 3 dimensions and 4 dimensions just fine. So let's actually create a 2-dimensional array with 3 rows, 4 columns. Everything in Python, just as it was in R, is stored as row, comma, column. So what we're going to be doing here is we want a NumPy array range of 12 values. So let's just look at what that would look like. I'm going to copy that, place that over. So it's just 0 up until 11. And then I want to reshape that. Reshape these 12 values into 3 rows and 4 columns. So now, run that, print A. So now we have 0 up until 11, but we have 3 rows, 4 columns. So let's just get some metadata here. So we can do A dot number of dimensions. There's 2 dimensions. It's a 2-dimensional array. A dot shape. It's 3 rows, 4 columns. Length of A is 3 rows. So the nice thing that we can do, and then we can also do it, the nice thing that we can do is we can multiply this array. So let's say here's our array A, 0 up until 11. Let's do A times 8. 0, 8, 16, all the way up to 88. So it's really quick at doing this math. And just like we can in lists, we can index and slice arrays here in NumPy as well. So let's say we have another array, and we want an array range of 10 values. So 0 up until 9. Let's say we want to grab the 3rd value. So A bracket 3. So we have 0, 1, 2, 3. And there we go. Now let's say we wanted to do A equals numpy.linspace. Or let's just do A range. Let's do 10 to 20 by 2. So A is 10, 12, 14, 16, 18. So now if we do the third value, it will be 0, 1, 2, 3, 16. So we get the 16 here. That is the third element within the A array, because 0, 1, 2, 3. So the other thing that we kind of I did up here and I glossed over, is we can reshape. So we can reshape any array into the size that we want. So if we have this array B and we just want it to be an array range of 12 values, I can use the dot reshape function and give it 3 rows and 4 columns. Run it just like that. Hit B, and there we go, just like we did above. And then I can slice this any way that I want. So let's say I want the first row, second column. So B, first row, second column, 6. So now remember here that it's 0, the 0th row, the first row, the second row, 0th column, first column, second column. So we have the first row, 0, 1, second column, 0, 1, 2, we get 6. So this is a confusing part of Python, but I just want to reiterate it. It is 0 indexed. So we can also just select an entire row at a time. So if we want to just grab the second row, 0, 1, 2, vice versa, if we want to grab the second column, we just need to put a comma before that. Whoops. We actually need to put a colon, comma, too, and colon just stands for all values. So if I had B, colon, comma, colon, bracket, it would just return the whole thing. And I could replace this one with 2. Oops. Rewrite that out just so it looks a little bit cleaner. And there we go. So we have the second row here, 0, 1, 2, second row. So now that we have a little bit more under our belt, I encourage you to do this exercise and just run through this. Create a null vector size 10. Create a vector of size 10, but have the 5th value be 1. So, and a null vector, what I mean is use NP zeros. So right here. So just to give you a little idea, so I have numpy.zeros, and let's say I want to give it a shape of 3, 4. Oops. Of 3. So 0, 0, 0, 3. So if I wanted 12 of those, and then if I wanted to reshape it, I could do reshape 3, 4. So it's just an array of zeros. So that's what I mean when I say null array. So run through that, see how you do. Now we can also, the other thing that we can do here with NumPy is we can do logical indexing. So we can select elements of an array using true, false values. So let's just say, whoops. Let's just say we have an array. It's an array ranged from 0 to 5. 0 up until 5, so that's what A looks like. Then we can have this selection NumPy array. It's a NumPy array we make from scratch. True, false, false, true, true. So selection just looks like this. Now what we can do is we can use that as a logical index of our A array. So this is what A looks like. Now we can do A and we can index it based on the selection. So in this case, it's only going to print the values where we have true under our selection. So 0, 3, 4, only where it is true. The other thing that we can do, which is super valuable, is we can use this kind of logical idea to only print values. Let's say we want A where A is greater than 2. So it only prints out 3 and 4. We can also use greater than or equal to 2. So 2, 3, 4. So those are different ways you can slice things as well. And this is a super critical thing, because there's going to be times where you have a data set, and let's say you have a sea surface temperature data set in Fahrenheit, and you have values that are 28 degrees Fahrenheit. Now we know water freezes at 32 degrees Fahrenheit, so those values might be invalid in your data set. So you might need to do something where you say, hey, given my temperature array, all values below 32 are invalid. They are NP NaN. So this is the other thing we can do. We have this selection, right? Let's say we wanted to reclassify those as NP NaN. Or in this case, it's because they're integers. So let's just say we had A equals NP dot array, and let's say we'll give it 1. Now if we have A where A is greater than 1, and now because they're floating points, so that's the error that I was getting, they needed to be floating points in order to convert it to NaN. Now we have 1 point NaN NaN. So these are different ways you can do that. So in our case, let's just say, just for completency's sake, let's just say we have an array, np.array, and let's say that our values are 34, 33, 32, 28, 28. Now what we can do, here's our temperature array. We can just say A, where A is less than 32, is going to equal NP NaN. Now we reprint A out, and we have NaNs where we had 28 degrees Fahrenheit. So these are just really important things that we can do here that might be useful with these arrays. The last thing that I want to get into for NumPy is masked arrays. So these are special arrays where we can mask out values given certain circumstances. For example, notice in this last little example that I did right here, we kept these as NaNs. But let's say we just wanted to mask those values out. We still want them to be part of our array. We don't want to change the shape. But instead of being NumPy NaNs, we just want to mask them out. So we want to have a placeholder there, but we don't want them to have any values at all, not even NumPy NaN. So an example of that, let's just make another array and let's reshape that to a 3, 4. So now here's A. Because I use this np.ma.arange, it is numpy.maskedArray.arange. So we're just explicitly saying that, okay, we want everything that we make, every array that we make or any function that we use, we now want to use the masked version of that function. So every single function has an additional version, which is the masked version of the function. This is one of those examples. So notice that our mask is false because we don't have any masks here, but our fill value is 9999999. Let's say we want to mask the second row and second column. Do it like that, and there we go. 0, 1, 2, second column, 0, 1, 2, second row. So there's 10. So we have 0, 1, 0, 1, 2, 0, 1, 2. So that is masked out, and it's masked via that dash dash. Now what we can do is when we do this math, we do math on this, we can do math on everything, but it doesn't touch the masked value. It still stays masked. And now what we can do is we can also do this logical masking just like we did above, only it's not going to give us that same error where we needed to have floating points. So right now, B looks like this, and now we have that Boolean, or otherwise known as logical operator, working on our mask. So saying, okay, false, none of these values are masked, but oh wait, we have a true right here. Why? Because that value is masked. And now I can print out A again. And same thing. And let's just say we want to mask out any values where A is greater than 6. So we're masking out 7, 8, all the way up until 11 there. So all of these values are masked. So now, come down here, print A. We have no mask, no mask, no mask, and then all of a sudden true. All of these values are masked. So, but it still keeps the shape. You can see it there, but if we run a.shape, still 3, 4. 3 rows, 4 columns. We can also unmask an element though. So let's say we have A, and let's say we wanted the 3rd column, 4th row. Oh, it's out of bounds. Why? Because we are 0 index, so we just have to subtract 1. So it's a masked value, and let's just say we want it to be 77. So now we print A again, and now we have 77 here, and now that value is no longer masked. So given all that, run through this exercise right now, and I'm going to stop this video just so this video is just for the introduction to NumPy tutorial, but I do expect you to run through the introduction to matplotlib tutorial for this week as well, as there's no assignment for this week.